Good morning, 8th graders, and welcome to virtual math class. Today we are going to be talking about proportional relationships, which you should remember a bit from 7th grade. So our objective for today is that students will be able to identify proportional relationships. So this will include looking at the constant of proportionality also. Okay, so let's look at our first example. It says, what relationship do you notice between an object's height and the length of the shadow? So I am given if I look at the table, I'm given the height of each of the younger boy, the man, the older boy, and then the shadow length, I'm given the height of the younger boy, the man, the older boy, and the lamppost. So I will be asked to find the height of the lamppost in just a minute. So in order to know the relationship that we notice, we need to look at the relationship between the height and the shadow length. So if I start by looking at the younger boy, I have 45 and 30. So I'm going to ask myself, what can I multiply by to get from 45 to 30? And multiplying by a number from 45 to 30 would be the same thing as dividing if I go from 30 to 45. So to figure out what that number is, I'm going to do 30 divided by 45. And when I do, if you just do 30 divided by 45, you're going to get like 0.666666666 repeated. However, I can also just write this as a simplified fraction, and each of these can be divided by 15, and 30 divided by 15 is 2, and 45 divided by 15 is 3. So now if I do 45 times 2 over 3, that would give me 30. So now let's look if the same relationship would exist for the rest of them. So if I do 48 over 72, is that equal to 2/3? Yes, it is, because I can divide both of them by 24. So 72 times 2/3 would also give me 48. And what about 34 over 51? Is that equal to 2/3? So 34, if I do 34 divided by 17, that would give me 2, and 51 divided by 17 would give me 3. So that again, 51 times 2/3 would give me 34. Now, I do not know the height of, since I don't know it, I'm going to call the height x. So now, if I do the same thing, so I would have 114 over x because I have my shadow height on top and my height on bottom, and I'm going to set that equal to 2/3 to figure out what it's going to equal. And I'm going to do my cross multiplying and divide. So if I do 114 times 3 equals 342, and then 2 times x would give me 2x. And now to solve this, I would divide both sides by 2. And if I do 342 divided by 2, that equals 171. So x would equal 171. Okay, that would be my height, the height of the lamppost. So did I multiply by the same number each time? Yes, you did. So since you multiply by the same number each time, that shows that it would be a proportional relationship. And now, what number did we multiply by each time? 2/3. So that would be our constant of proportionality. Go to the next slide to see what those words mean. So what is a proportional relationship? In a proportional relationship, the values for one quantity are multiplied by the same number to get the values of the other quantity. So if I look at this table here, I have S and P. So do I multiply by the same number each time to get from S to P? So how do I get from 2 to 8? That's multiplied by 4. 2 times 4 equals 8. What about 3? Does 3 times 4 equal 12? Yes. What about 5? Does 5 times 4 equal 20? Again, yes. What about 10? 10 times 4 equals 40. So since I can multiply each of those by 4, each S I can multiply by 4 to get to P, that would be a proportional relationship. If I had, let's just say I had 11 and then I had 45. So 11 times 4 would not be 45. So if I have one example where it does not work, that would mean that it would not be proportional. However, that's just one example. So if I didn't have that, then yes, it's proportional. So the constant of proportionality is that number that you multiply by. So it's the number you multiply by. So in this case, what number did I multiply by each time? I multiplied by 4. So my constant of proportionality in this case would be 4. Okay, so on this one, it says, when a truck full of boxes arrives to Weston Post Office, Isaiah unloads a truck by placing the boxes on a conveyor belt. Isaiah's workers are impressed with how fast Isaiah does his job. There is a proportional relationship, so it already tells us there's a proportional relationship between the time in minutes Isaiah spends unloading the truck, X. So X is the minutes, and the number of boxes he unloads from the truck, Y. So we have X that's in minutes and Y that's the boxes. And then it asks us, what is the constant of proportionality? Write your answer as a whole number or decimal. So remember that the constant of proportionality is the number that you multiply by to get from X to Y. So X is 3, Y is 18. 3 times what number will get me to 18? 6, right? So 3 times 6 is 18. And then I need to check to make sure. 6 times 6 is 36. 7 times 6 equals 42. And 8 times 6 equals 48. So my answer here would be 6 boxes per minute. In our last example, it says, every day after school, Fred and his sister Brenda played their favorite video game, Wizarding Legends. The goal of the game is to earn power points by defeating goblins. This table shows the relationship between the number of goblins defeated, X, and the number of power points earned, Y. So we have X that's goblins and Y that's power points. It says, according to the values in the table, do X and Y have a proportional relationship? So in order to see if they have a proportional relationship, we need to see if they have a constant of proportionality. So 8 times what gives me 56? 8 times 7 equals 56, right? So does 12 times 7 equal 84? Yes. So 12 times 7 equals 84. What about 13? Does 13 times 7 equal 91? Yes. What about 14? Does 14 times 7 equal 98? Yes. So since on each one I multiply by the same number, that means that yes, it is a proportional relationship. And our constant of proportionality would be 7 because that's what I multiply by each time. And we are done. So that concludes today's lesson. I hope you have a great day. And if you have any questions, please just reach out and let me know.